Welcome back, DIMO drivers, and as the saying goes, location is king. And we here at DIMO have been working to improve the accuracy of our geolocation. This is Matoush, and he's one of our code ninjas.
I gave him an impossible task, a job no one could have pulled off.
His challenge was to improve the accuracy of our geolocation without increasing our 33-byte payload on the macaron. Why 33 bytes, you might ask? Well, it's all about range. Think about AM radio versus FM radio, if you're old enough to remember those things. Now, 33 bytes might sound like a big runway, but each frame has to have a header, timestamp, last 8 of a VIN, and other card data points. Here's an example of a frame. Each one of these frames is sent every 30 seconds. As you can see, there is a lot we have to squeeze into it. Oh, did I mention that he took the current 64 bits we were using and got it down to 51 bits? Because yeah, that happened. But how did he do it? So if you know anything about maps or ever taken the time to look at a globe, you would see longitude and latitude lines. Each of these have a range. Latitude has a range of -90 to 90, and longitude has a range of -180 to 180. This makes it where you only need 8 bits for latitude and 9 bits for longitude. Why does this matter? Well, let's say you got this lat long respectively. This is way too large, honestly. Why? Well, if you were using this coordinate as a mapping point, you would need a microscope in order to see it. Bonus points for anyone that can figure out where this location actually is. With this in mind, he cut the decimal places down to 5, which is a 1.1 meter accuracy. Just to put this in perspective for you, that's a higher precision than a US JDAM missile. But for Matoush, that was still too large. Cars are generally moving, and each time a frame is sent, you would have covered some sort of distance, or what we like to call in our case, a difference. This is where the science comes in, and if you've ever seen this meme,
the missile knows where it is at all times. It knows this because it knows where it isn't. By subtracting where it is from where it isn't, or where it isn't from where it is, whichever is greater, it obtains a difference or deviation.
Yeah, that's basically the gist of it. Since we are sampling so frequently, the distance you can travel even at high rates of speed isn't massive. This will make it where we can actually store less digits, thus equaling a smaller bit requirement. With this newly found wiggle room, we can sample more location data to get a more accurate route. At the end of the day, this is a big win for DIMO users. Now you will be able to get a more accurate location, and when we launch our trips feature, you won't see your car driving in the ocean. For our developers building on DIMO, now you will have a better trips API to work with. That's all I have for you today, DIMO drivers, and we'll see you in the next one.